ligas para videos de ayuda y compra de accesorios. Importante: sugerimos que hagas un buen análisis y las pruebas necesarias para que por tu propia cuenta y experiencia hagas la mejor implementación de los consejos que aquí presentamos. El tiempo que inviertas en la revisión de estos videos será muy valioso y te llevará a mejores resultados. El cliente es responsable de informarse, probar y decidir por cuenta propia qué soluciones son más favorables y seguras para el proceso de corte a 45 grados. Con este pequeño tutorial, podrás configurar los videos de YouTube para que se traduzcan de manera automática. ¿Cómo lograr cortes precisos a 45 grados? Explicaremos las variables para conseguir realizar cortes a 45 grados con toda precisión a todo lo largo de los cantos de los frentes que llevarán el perfil Aero 45. El paso 1 es calibrar el disco de tu sierra con un ángulo exacto a 45 grados de inclinación respecto de su plancha. La forma más sencilla de lograrlo es con un buscador de ángulos digital o inclinómetro. De esta manera, podrás garantizar que el sistema de colocación instantánea de los perfiles EasyFix funciona adecuadamente por largos años.
Setting your table saw blade angle with a digital angle gauge eliminates guesswork and ensures precision cuts every time. And best of all, it's easy to use. Let's get started. First, always unplug your saw before doing any maintenance. Next, we'll raise the blade to its highest point so we can check the angle. Loosen the 0-degree adjustment screw. The adjustment screw stops the blade at 0 degrees. Place the digital angle gauge on the table. Turn the gauge on, zero the gauge, place it on the blade, and check the angle. Use the bevel handle to adjust the angle to 90 degrees. Once the angle is at 90 degrees, lock the bevel handle in position. Then tighten the adjustment screw. The last thing to do is adjust the bevel indicator so it's set to 0. That was easy, right? Okay, now let's adjust the 45-degree angle. Set the blade to 45 degrees, loosen the 45-degree adjustment screw. Next, remove the front plate and use the bevel handle to adjust the angle to 45 degrees. Just like we did earlier, place the digital angle gauge on the table, turn the gauge on, zero the gauge, place it on the blade, and check the angle. Again, use the bevel handle to adjust the angle to 45 degrees. Once the angle is at 45 degrees, lock the bevel handle in position. Then tighten the adjustment screw. That's all there is to it.
Puedes adquirir el buscador de ángulo digital en Amazon buscándolo como inclinómetro digital. Este video explica claramente las variables para realizar los cortes a 45 grados de manera más amplia.
Number 1, break down your sheet goods into manageably sized pieces before you rip the bevel onto them. Whenever you rip pieces that are close to what your finished dimension is going to be, that's going to allow you to keep that piece held down nice and tight to, number 1, the table saw base, and number 2, keep it tight to your fence. If you're trying to put a bevel on a big old sheet of plywood that might not be perfectly flat, you may find the different parts of that sheet do not want to sit down nice and tight to the table. If you're ripping a really long board and you're having to stand way back and push it through, you might find it's difficult to tell if you're making good contact with the top of the table. So do whatever you need to do to ensure that you're machining your wood really precisely. One of the easiest ways for me to ensure that is to break down the large sheet of plywood into smaller pieces and then rip the bevels after that. And then always be aware that if you don't have straight edges, it's going to be a little bit more difficult to get that perfect miter on those pieces.
En este video encontrarás cómo puedes fabricar tus propios tableros de plumas con los que podrás ejercer presión vertical y horizontal mientras realizas los cortes de tu sierra.
Recently, I made this featherboard for my table saw. Okay, it goes into the miter slot and it holds the piece of the timber, wood or anything you're cutting against the fence, and it works absolutely brilliantly. Okay, so I'm going to be using this to create a featherboard that will attach to the fence itself. Okay, so we're going to be able to use it vertically, pushing the piece of timber, anything else you're going to be cutting down to the table of your saw. I'm just gonna roll a 1-minute clip so you can see how you can quite easily get to this stage. First of all, the material I'm using is 18mm MDF. It's not perfect choice of materials, but that's what I've got in my workshop. However, plywood or hardwood would be far better if you've got it. Now, as you can see, I'm actually using my miter saw to tackle this project, to cut out the feathers themselves, and I'm using some spacers to make sure the feathers are at equal distances. Okay, so we have arrived at this shape. I'm just going to be cutting it out. I've marked some lines here and there so I can achieve the particular shape I want. In my case, I'm using a bandsaw to make the cuts. However, if you've got a jigsaw or just a normal handsaw, you can do these cuts quite easily. Now, the feathers themselves, they're way too long for what we need, so I'm going to trim them with my bandsaw as well. With my pillar drill, I'm just going to pre-drill some series of holes on each side of this feather board. That will allow me to create a channel for the bolts so I can attach it to the fence. And after that, I'm just going to clean it up with a rasp. Now we need to think how we're going to mount the feather board onto our fence. Well, okay, so we've got a piece on top that's the same width of our feather board, just like so. So it's going to go like that. Okay, that's going to be the base on our fence, and we're going to use the back T-track just over here. Just going to mark the middle for it so we can pre-drill some holes for some bolts. Okay, so that's our base that will be on the fence itself. Now we need another piece that will go just like so. Okay, we need to pre-drill 2 more holes for the bolts to go through, and these will be holding the feather board to our contraption that's located on the fence itself. Okay, so I'm going to pre-drill the holes, then I'm going to glue this to that and add some additional screws to make sure it's a nice and steady connection. Now I'm going to add a slight countersink to 2 holes in the vertical piece. Thanks to that, I will be able to hammer through the bolts and basically get them stuck inside of the MDF so they won't spin when I'm going to be adding the knobs to secure the whole thing. Right. Goes like that. To secure the base to the fence itself, I'm going to be using some washers and wing nuts. Now I'm going to add the feather board, and to secure the feather board I'm just going to be using some plastic knobs and 2 larger washers. Now, as you remember, this feather board, okay, needs to be, the last feather here needs to be before the blade. Okay, that's very important, and I said that in my last video. However, with this one, that's not the case. Okay, that is just pushing the piece that we're cutting through to the table, so it's got nothing to do with the blade, so we can place it accordingly when we want it. So I'm just going to make sure it will stay here. I'm going to lock it in place to our fence. Okay, this is now super solid. Let me just put that right up so you can see it better. Okay, and this is solid. This is not going absolutely anywhere. Okay, let's set this up and let's give it a test. Right, so I've got both of the feather boards set up just like that. As you can see, that's holding it down, and this is really stable. Okay, this is not going absolutely anywhere. It's actually very difficult to pull this out. Okay, let's give it a spin.
Una forma de garantizar un ángulo a 45 grados y su continuidad a todo lo largo de los cantos largos es realizando el rebaje a 45 grados con un trompo y tableros de plumas. Recomendamos que para cualquier nueva técnica que quieras implementar, hagas las pruebas necesarias con material de desecho y contemples la logística de las piezas según su tamaño y la longitud del canto que llevará el perfil. El método de este video es recomendado para frentes de cajón con el canto a maquinar más largo que el ancho o alto de las piezas. Por ejemplo, un frente de cajón de 1,20 m de ancho por 15 cm de altura que llevará el canto al 1,20 m de largo, y para piezas todavía más largas como pueden ser puertas de lockers con hasta 2 metros de altura o más que no excederán los 60 cm de ancho, en cuyo caso solo se dejará el peine para hacer la presión vertical de la pieza a maquinar y la presión horizontal se haría al mismo tiempo que se van empujando por el operador.
I've got a lot of 45-degree miters and bevels on the table saw, and if there's one thing I've learned, it's that setup is only half the challenge. Sure, your blade has to be tilted to a precise 45-degree angle, and your fence must be perfectly parallel to that blade. If you screw one of those things up, you're going to have a bad day. But perhaps the greatest challenge is consistently feeding the boards straight through the cut. If you allow your workpiece to drift away from the fence at all, if your fence deflects a tiny bit, or if you pause mid-cut, you may get gaps in your assembled joint. I'm not saying you can't do it at the table, so I've done it plenty of times. I'm just saying it can be a fussy process, and perhaps a router table might be a better tool for some jobs. Think about it. A 45-degree chamfer bit can't be set to the wrong angle. The bit cuts at a single point, so the fence doesn't have to be parallel to anything. And it's easier to keep your work firmly against your router table fence as you cut, because you can use feather boards to apply pressure in places that might lead to a serious kickback if you do it at the table saw. These advantages can lead to straighter, more consistent bevels at the router table, both on the edge of the workpiece and on its ends. But there are some techniques involved, and that's what we'll discuss in this video. I think that the larger bit is worth the investment. I'll link to the one I used below this video. Now, since this bit is capable of removing the entire edge from my workpiece, I have to consider how the fence will guide the board on the exit side of the cut. For example, if the bit removes too much of the edge, a gap will appear between the fence and what remains of the board. At the beginning of the cut, this won't matter much because the uncut portion of the board is still running on the infeed side of the fence, and that'll support the workpiece. But eventually, you're going to reach a tipping point where a shift will occur to close the gap on the outfeed side and open a gap on the infeed side. This shift can leave a mark on your beveled edge, and you will get some nasty snipe as the bit exits the cut on the end of the workpiece. There are two solutions to this problem. The first is to set the bit height so the bottom corner is just above the surface of the table. Then set the fence so the bit will cut almost, but not entirely, to the top of the workpiece. This will leave a flat portion at the top of the bevel, which can ride against your fence and support the cut. Of course, you'll want a crisper, more knife-like edge. So move the fence back a tiny bit more and make another cut. The goal is to incrementally reduce that flat edge to a hair's width without removing it entirely. It may take a couple test cuts, but once you get your fence dialed in, you can lock it down and then cut all of your workpieces. The second method is less fussy, but it's perhaps only practical for shorter workpieces, because it involves using some double-sided tape to attach a scrap piece of wood to the top of your project part. This guide board will run against the fence so you can remove the entire edge of your workpiece beneath in a single pass. Note how both these methods led to a crisper cut. Here, I'm cutting across the grain on some veneered plywood and I'm removing the entire edge. This is a worst case scenario because that thin outer veneer is so delicate, and you can see how I got fuzzy fibers along my sharp edge. If I employ our first method, which left that tiny blunt edge, I don't disturb the delicate veneer and my cut is much crisper. That blunt edge, if it's very fine, won't be noticeable after you sand your assembled joint anyway. On the other hand, if I employed our second method by applying a guide strip above the workpiece, it will help support those delicate fibers beneath it even if I do cut away the entire edge. Also note how the feather boards on my fence hold the workpiece down on the table, while my hands push it toward the fence and guide it forward through the cut. You could add featherboards on the tabletop to push toward the fence as well if your workpiece is narrow enough. As I said, the ability to apply consistent pressure wherever you need it is one of the biggest advantages of using a router table for this task, so I recommend employing featherboards wherever you can. Cutting bevels on the end of a narrow workpiece presents an additional challenge because you have to keep the piece perpendicular to the fence as you cut. One of the simplest ways to do this is with a pusher made from a wider piece of scrap wood. The pusher has the added function of also supporting the fibers on the trailing edge of your workpiece so the router bit won't leave splinters as it exits the cut. This is a far greater concern when I'm cutting a board's end across the grain than if I was routing the edge with you. You must take care to hold the workpiece firmly against the edge of the pusher so it doesn't slip towards the bit as you cut. With proper care, you can make very accurate cuts using this method at the router table as opposed to a table saw.
Puedes adquirir las plumas de plástico en Amazon buscando tableros de pluma y tableros de pluma para guía. El carro deslizador reduce de manera importante los rollos al cortar y al mismo tiempo facilita la operación de corte, contribuye a mejorar la precisión y reduce la fatiga del operador. Se recomienda principalmente para cortes en el canto más corto de la pieza, especialmente si las puertas son muy largas, como pueden ser una puerta de 1,20 m de altura por 60 centímetros de ancho, y el corte será realizado en el canto de 60 centímetros de ancho.
In my last video, you may have seen me cut 45-degree bevels up against my fence like this without using a sled. Cross-cutting against the fence is usually a no-no for safety reasons, and while these panels were wide enough for me to feel safe doing this, I figured it was time to build a decent 45-degree cross-cut sled. It's dead flat and has the advantage of being lighter than plywood. The first step will be to cut the base to size. I randomly decided to make the sled 36 inches wide, which should be long enough to support the types of panel I expect to cut. I decided to make it no bigger than the depth of my saw, which is 27 inches. I fenced 27 inches and made the cut. Next, it's time to make the runners, which are key to the success of this sled. Slide nicely without any side-to-side play, so this looks perfect. Without adjusting the fence, I cut the second runner and tested it as well. Just as expected, it was a perfect fit. Woo! Now I can set my fence to 3/8, flip the runners on their side, and rip down the fence. At 3/8, they should sit just below the surface of the table, which is perfect. Next, I'm going to attach the runner to the sled. Since my blade tilts left, I decided to skew the sled to the right of the blade so that I'll have more support for long panels. I set my fence at 26 inches, and that way the blade should be just around here. Because the runners sit below the surface, I'm using a few pennies to raise them up so they'll make contact with the panel. Canadian pennies were phased out in 2012, but I keep a few on hand just for it. Here I'm applying a very thin bead of melamine glue, not too much so it won't get all over my table saw. Then using the fence as a reference, I can just drop in the panel and simply make sure the runners are aligned with the edges. I added some weights on top of the runners and let it sit for about an hour. Looks like it worked, so I can now permanently attach the runners with screws. I carefully made some pilot holes using a countersink bit and secured the runners with some number 6 1/4-inch screws, making sure the heads were sunk. Okay, let's give it a try. Wow. Maybe I got lucky. Maybe it's the laminate, but boy does this slide smoothly, and I haven't even added any paste wax yet. Next, I'm going to add a back fence. And just a note that at its highest my blade only reaches about 2 1/8, so the fence doesn't have to be too high, nor does it have to be full length, just enough to cover the run space. Just to make it smoother to the touch, I'm going to round the corners using my bench sander. Then I'll use a roundover bit to break the sharp edges. Okay, so now I can just clamp the back fence on. It doesn't have to be square, it's really just here to hold the sled together. I made pilot holes using a countersink bit and attached the fence using number 8 1 1/4-inch screws, making sure to avoid the area between the runners where the blade will pass. Next, I set my blade to 45 degrees, making sure to be super accurate. then ran the sled through to cut the curve, but stopped just short from the front edge, leaving a few inches intact. The front fence needs to be dead flat, so I first thought about using some more laminate, but the particle board core is brittle and won't hold screws very well, so I was afraid it wouldn't hold up. So instead, I'm going to glue a few pieces of 1/2-inch plywood together, which should help keep them flat. I'm using 3 pieces of 1/2-inch, but 2 pieces of 3/4 inch should work just as I added ample glue and spread it around. If you're wondering why I'm doing the glue up on the table saw, it's so I can use the fence as a backer and clamp these fences together. Pun intended. While the glue was still wet, I took the time to scrape off the excess before it dried, so I didn't have to scrape it off later. While I'm at it, I used a chamfer bit to make a tiny chamfer on the bottom edge of the fence, just so the sawdust will have somewhere to go without getting in the way. Now the front fence needs to be perfectly perpendicular to the blade, and to do this I'll first add a screw on the left end, then adjust the right side. Using a framing square, I adjusted the fence until it was perfectly square with the correct line. I really took my time here, checking on both sides of the blade. When I was satisfied, I delicately added a clamp, then checked it again to make sure nothing had moved. I added a single screw from underneath, then one more towards the middle using a straight edge to make sure the fence wasn't bowed. Before adding any more screws, I'm going to test it out for accuracy. Now there are some very precise ways to do this, like the 5-cut method, but I'm just going to cut a large panel in half, then flip over one piece and see if the seams line up, without any gaps. So here it is again. After making the cut, I flip one piece over, and making sure to butt both pieces up against the back fence, I gently push them inward. You can see the seam lines up perfectly. That's good enough for me. If the seams don't line up, adjust the fence to secure it using a new screw hole and test it again. If you're lucky like I was, simply add some more screws and you're done. Now for example, if I wanted to cut a 13-inch panel, I just make a mark and then line that up with the inside of the curve just like this, and then make the cut. Okay, let's test it out. Yep, exactly 13 inches. In the end, the laminated particle board turned out to be a great choice for making a sled. It slides super smoothly on the table without friction, sturdy and dead flat. And my concerns about the panel sliding around when I made the cut were completely unfounded. I definitely recommend trying out laminate for your next sled. In my next video I'll be making floating shelves using the sled, so be sure to check back for that video or subscribe to my channel to get notified when I post new videos. Until next time, thanks for watching, see you soon.
Importante. Sugerimos que revises a fondo las reviews de cada producto, así como tu propia investigación de las diferentes opciones antes de comprar cualquiera de estos productos. Existen varias críticas de los usuarios en estos videos con los que podrás recibir las experiencias, pros y contras que te pueden orientar para una mejor decisión de compra o de fabricación. El tiempo que inviertes en este proceso será muy valioso y te llevará a mejores resultados. El cliente es responsable de informarse y decidir por cuenta propia su elección. Encuentra los datos de contacto y más información en nuestra página escaneando el código QR. Nos dará mucho gusto atenderte y participar en tus proyectos. Gracias.